Welcome back to Discovering Geometry with Mrs. Berry. This is Lesson 17. In Chapter 1, we learned that an angle bisector divides an angle into two congruent angles. Today, we're going to learn how to construct that bisector. So our first investigation, we're going to need that patty paper or tracing paper and something to draw or write with. Also a straight edge so that you can make good angles. First, I want you to draw a large-scale acute angle. Label it PQR. Then fold your patty paper so that ray QP and ray QR coincide. Crease the paper along that fold. Unfold your patty paper. Draw a ray with endpoint Q along the crease. Does that ray bisect angle PQR? How can you tell? Repeat these steps again with an obtuse angle. Do you use different methods for finding the bisectors of different kinds of angles, or was it all the same? How did you know that your ray bisected the angle? Did you measure it? Make sure that you try this investigation on your own before watching the video. Here's acute angle PQR. Now I'm going to fold this paper so that the two sides of the angle line up with each other and the crease is on the vertex. Then I'm going to crease that paper, unfold it, and draw a line in my crease. So this is the ray that bisects the angle starting with point Q. I chose to measure my angles with a protractor so that I could make sure that these angles were congruent. So these angles are congruent. Now I'm going to start with an obtuse angle. Again, I'm going to make sure that the crease is right on Q, and then I'm going to line up the two sides of the angles so that they're right on top of each other. Crease that paper, unfold it, and draw that ray where the crease is. I'm measuring my angles with a protractor to see if they are congruent. Did I have to do anything different with the obtuse angle than the acute angle? I didn't. I was able to use the bisector in the same way. I'm going to label a new point A on my angle bisector. I'm going to compare the distances from A to each of the two sides. Remember, the distance needs to be the shortest distance. So it should be perpendicular with the side of your angle. Try it with other points on the angle bisector and compare your results. Here are pictures of my acute angle and my obtuse angle. You can see that I have a 90-degree angle down here, so that is my shortest distance to point A. What do you see about the shortest distance from point A to both sides of the angle? So remember, A is on my bisector. What is the distance to both sides of the angle? The angle bisector conjecture says if a point is on the bisector of an angle, that would have been my point A, then it is what from the sides of the angle? It is equidistant from the sides of the angle. We saw that the shortest distance to both sides of the angle were the same from that point A. And I could have chosen another point further up or down on that angle bisector, and they would have had the same distance to both sides. Now, we don't always have tracing paper or patty paper. Sometimes we need to go back to just a compass and a straight edge. How would we bisect an angle with just a compass? In this investigation, you need to come up with your own procedure. So draw an angle on patty paper, or you can use regular paper, and find a method for bisecting that using just your compass. I'm going to give you a few hints. Start by drawing an arc centered at the vertex. So here is our angle. If I center an arc here, so I'm going to put my compass point here, and I'm going to just draw an arc across my angle. What does that mean about this point where the arc intersects this side of the angle and the other side of the angle? What does that mean? It means that this distance is the same, right? Because your compass setting didn't change as you drew that arc. So if this is X, then this is X. Now, what else have we learned? That angle bisector that we want somewhere in here, I'm going to draw it with a dashed line because I don't know exactly where it is. Anywhere on here would be equidistant to both sides of the angle. So how can you incorporate that to figure out where this point would be? When you think you have it, check by folding your paper and see if that angle bisector is in the crease when you put both angles sides on top of each other. Make sure you write down your procedure when you get it all situated. I want you to pause the video and try this on your own before you see the answer. So here is how I did it. I have this angle, and I used my compass to just draw an arc across the angle. That means that where the arc intersects the sides is the same distance. Now I'm going to start on that new distance point, and I'm just going to draw another arc further up in the angle. And if I keep my compass setting the same as I do that, I have now found a point that is the same distance from the points that I crossed at in my arc, my original one. If I connect that to the vertex, what does it look like? It looks like the angle bisector. Definitely fold your paper along that angle bisector and make sure that the sides line up. So what else can you do now? You've learned how to construct a 90-degree angle when we did perpendicular segments. And you've now learned to bisect an angle. So if I have a 90-degree angle and I can bisect it, what other angles can I draw? Well, this would be 45, right? Now, what if I take that 45-degree angle and I cut it in half again? If I draw another bisector, what angles can I make now? 22.5 degrees. What if I wanted to bisect that one again? How many angles can you now draw without ever having a protractor, just using a compass? Quite a few. You have lots of skills built up now. Thanks for watching. See you next time.